Look at the steel, glass, and concrete rising in this time-lapse. Now think about the water you drink, or the air filling your lungs. That is all matter, anything that has mass and occupies space. The sheer variety of these materials is staggering, yet every single physical object you interact with is constructed from the exact same microscopic toolkit. This is an atom, the indivisible unit of all matter. It is the foundation of reality, the only way to decode the physical universe. Watch it multiply. A substance made entirely of identical atoms is an element, the purest form of matter. Every element possesses a unique fingerprint called an atomic number. This identification system, based on the atom's structure, tells you exactly what raw material you are looking at. On the left of this frame, we have a dense nugget of raw gold. On the right, a sealed glass sphere containing oxygen. They inhabit entirely different states of matter, but both are pure elements. The defining rule of an element is its permanence. No physical or chemical force on Earth can break that gold nugget down into anything simpler than gold atoms. Elements act as the universe's unbreakable alphabet. Without these pure, immutable letters, the complex language of matter cannot exist. But atoms rarely stand alone in nature. So what happens when different elements are forced to lock together? You get a compound. This occurs when elements chemically combine under strict, unyielding mathematical rules. These floating spheres represent hydrogen, a flammable gas, and oxygen, which fuels combustion. Separately, they are volatile, but when two hydrogen atoms snap together with one oxygen atom, they lock into an exact 2-to-1 mathematical ratio. Watch this droplet of water strike the flame. Two explosive gases chemically bonded to create a liquid that extinguishes fire. Chemical bonding destroys the original identities of the elements involved. They sacrifice their past to birth entirely new substances with unrecognizably different properties. Now, consider what happens when elements or compounds occupy the exact same space, but actively refuse to chemically bond. Swirling these shapes loosely creates a mixture, a physical blend retaining original properties. Grouped unevenly, it's a heterogeneous mixture, like sand and water. Diffused perfectly, it's a homogeneous mixture, like sugar dissolved in water. The thorough blend tricks your eye into seeing a pure substance. This pristine stainless steel spoon looks exactly like a pure metal element. In reality, it is an alloy, a homogeneous mixture of iron, carbon, and chromium, physically blended to resist rust. Mixtures serve as the universe's ultimate compromise. They allow us to borrow and combine the strengths of different materials without permanently altering their chemical nature. To sum it up, compounds are governed by fixed ratios and chemical bonds. Mixtures are governed by variable ratios and physical blends. Knowing whether a substance is an element, a compound, or a mixture dictates exactly how we can isolate, combine, or shape it for a specific purpose. Look at this massive steel suspension bridge. Engineers rely on physical mixtures, exploiting the strength of metal alloys to span these vast gaps. Chemists exploit compounds. By forcefully bonding specific elements in laboratories, they synthesize life-saving medicines that do not occur in nature. And as we fly over this smartphone motherboard, you see the work of technologists isolating pure elements like silicon and gold to drive modern communication. This classification system provides the logic for modern engineering. It allows us to deconstruct the world into its fundamental pieces and reassemble them into the structures of our daily lives.